You ready? Mm-hmm. Hello, General Chemistry 2 students. We are Professors Carl Snipes and Elizabeth Snipes. I'm Carl. This is Elizabeth. We are going to do, we are the chemistry department at SCC. That stands for Southeastern Community College. We're going to do Le Chatelet's principal experiment. Le Chatelet is French for I love chemistry. This experiment is experiment number This experiment is experiment number 11 in your lab, man. You all. Do you have any comments to make before we begin?
I'm looking forward to this.
Okay, well then. I'm glad y'all are so enthusiastic about it. Yes, 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 yes. Okay, Libby, do you want to explain anything that we're doing before we do begin?
Just in general, this whole online business, just kind of keep us posted if you have questions or concerns, and we're here for you. And we've come up with what we think will work just fine. But as far as this experiment goes, Le Chatelet's principle, gotta love it. It makes sense.
It's a fun experiment to do, and I'm sorry that y'all don't get the chance to do it, because we will enjoy doing it. Not ideal, but it'll work okay. Our daughter Wendy is home from Iowa State, and she's our camera person today, and so she'll be trying to zoom in as we need to so that y'all can see everything. And for your lab report write-up, what you'll do is with each of the 4 experiments, you need to explain not just what you saw, but why, in terms of Le Chatelet's principle. We did give you a good bit of background information in the experiments write-up, more than we should have probably. So it kind of, tells you what's going on there. So as you prepare, look at that. It's very,
So
very
for the
helpful.
write-ups, they just need to discuss, like you said, what you saw. That's all the calculations otherwise.
Yeah, there's no
this
quantitative parts really, just what you saw, and explain what's happening in terms of Le Chatelet's principle. We have systems in dynamic equilibrium. We're going to put a stress on that system. A lot of the stress is going to be adding or removing a species, maybe a reactant, maybe a product. We'll also, with the cobalt-2 chloride equilibrium, look at effects of temperature and such. So.
All right.
You want to do the first one?
Oh, yep. So we'll go ahead and get started with the first one. And can we see it projected? I know for my students, you're used to me writing things on the board, and like Dr. Snipes said, I think this is kind of, you have a lot of information. Before the experimental procedure, it basically kind of hints at what you should be seeing based upon Le Chatelet's principle.
Yeah, let me go back to that.
So, yeah. So this is the first one we're going to be doing.
Again, we explain it pretty well,
Yeah.
but again, you'll have to go back over with what we do today.
Yes, yeah,
But
definitely.
I'm going to go to the procedure so it's handy for us to
Yep.
see.
So you can see that first little paragraph, that's all I want to do right now. So actually I've got, in addition to, when it says, by the way, the different volumes, I've actually, in my class, this is something different for you guys. We've got 3 different sizes of disposable pipettes. We've got one here that's about 3 milliliters. So for this first set, all I've done is to go ahead and take about 3 milliliters of this 0.1 molar, is it potassium chromate?
I think, yeah, I think
Yeah,
it is.
chromate is
Or
what
maybe
I'm
seven, I can't
after.
remember.
So 0.3, and then I'm going to stress it in a few different ways. So I'm looking at the instructions here. It says add 3 molar H2SO4 dropwise until a color change occurs. So I'm going to set my control aside, and we'll come back to that.
Yeah, the control is just so, it's never going to change. It's just going to be there so that you have something kind of to compare to. The procedure doesn't tell us to do that, but we thought we would do it
Yeah, you
here
might want
since
to point at the control because I didn't.
Here's the control. I'll just have them both up there.
You want me to hold one for you?
Yeah. So is the background okay? Can you see the color? This is
Yep,
what you guys are
yeah.
gonna have to write about. By the way, in the background, it says that, is it dichromate is a different color than chromate?
Right.
Okay, so this is the chromate species.
It's
I'm
in
gonna stress
equilibrium,
it.
but right now, it's the chromate is the dominant species.
You guys see
Equilibrium-
that?
The equilibrium position is favoring the chromate.
It says until something happened, and I see something happen, Dr. Snipes.
Very good. Oh, wow, that was fast.
That was
Okay.
fast, okay.
So now the dichromate is the dominant species at equilibrium. These are both equilibrium systems between chromate and dichromate ions. But at this point, the chromate is the dominant, and at that point, the dichromate is.
Hint, hint, so explain how that happened in terms of adding H2SO4, which added H pluses, right?
Correct.
Now, this next thing I'm gonna add actually is 3 molar NaOH, and one of the things we talked about in Chem 1 was how hydroxide OH would react with the H pluses I've added in the form of H2SO4. So of course, NaOH is going to gobble up some of those H pluses. So
And form water.
yes, but
So-
we'll be removing H pluses. See what happens. 1, 2 drops. Oh, wow, 2 drops. Ding, 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 we have a winner.
Oh, well, why don't you add some more of the H2SO4 to it?
It doesn't tell me?
Let's do that
Okay.
anyway.
All right, so here comes some more H2SO4. What do you think is going to happen? I'm going to shift the equilibrium now to the dichromate, so the chromate.
And now, one more time, the NaOH.
All right. So it's going to go from orange dichromate to yellow chromate.
How about, we could do that again and again and again, but I think that's enough.
Okay. Very good. Next one?
The next equilibria is involving cobalt-2 chloride complexes. Let me go to the, I got it on the procedure right there. I'm going to go back up to the part that kind of addresses the chemistry just a little bit there. And that's, again, these are in your lab manual. So there's the chemical equilibrium equation that's pertinent here. So the procedure says to measure out 3 milliliters of the cobalt-2, the 0.1 molar cobalt-2 chloride solution, which is this nice pretty pink color, into each of 3 test tubes. We did it in a 4th test tube, again, just as a control. This one is just going to sit in the rack and stay at room temperature, not going to add anything to it or anything like let me go to the procedure again now.
Yeah, I do have.
Oh, you did for it. Sorry about that.
Thank you.
Okay. To one test tube, add about 2 milliliters of the concentrated HCl, which is here, okay, and a 2 milliliter dropper pipette.
Want me to hold them up?
No, I'm good for now. It says add an HCl there. Okay.
I don't see anything happening. Oh, looks still pink to pink.
Stand still.
And then to the second test tube, add about 1.5 grams of NH4Cl, ammonium chloride, which I've already conveniently measured out.
It looks pink to me.
But look at the control. Doesn't it look a little different colored pink?
Oh yeah, it
It looks,
does.
it looks
Hold on. We'll see.
pinker. It looks even more pink. Fill the test tube.
Ooh, it's cold.
Okay.
Ooh, very
So we've actually
endothermic.
decreased the temperature there a little bit, actually. Okay.
Cool it down.
Let's
That's
say back
one
to the
way-
HCl one.
Little.
A little warm, but not
Little
much.
warm.
Okay. And then to the third one, we're not going to add anything. And let's see, record your observations. Let's see here. There's our control. Here's the one with the NH4Cl. Here's the one with the concentrated HCl added to it. Both are, all 3 are still very pink, so to speak, which again, if you read the explanation with what we said in the background information, would you go back to the background information, please, Ned?
Oops, one more. There we go.
And then scroll so that the whole thing's on the thing. Thank you. The cobalt-2 water complex is pink. That's the species on the left-hand side. So right now the equilibrium is very much reactant favor. We're now going to put the 3 test tubes in a water bath. I think we can tell, I didn't mark them, but I think we can tell which one
Did you want to mark
is...
it? Oh, there it is. Tight right there.
Which one is which? I'll write HCl here and then H4Cl here. I think you're instructed to mark them first, right? And I will put it, this is on a hot plate, it's been heating up. It's very, very warm. We'll put it in a water bath and...
Can you see that, huh? Oh, because I can see that. And
Hello, I look a little bit different because it's another day. We had an editing glitch, and so we lost the very last part of this experiment and the beginning of the next equilibrium experiment with the cobalt-2 chlorides equilibrium. So I'm just kind of picking up with where we lost it off. So here are my 3 test tubes, the one with the HCl in it, the one with the ammonium chloride in it, and then the control with nothing in it, and then I've got a room temperature control here as well. And so I'm ready to put them in my hot water bath and heat them up and see what happens. And you can probably see the color changes that are taking place as it's heating up. If you look at what's going on here, when the cobalt water complex is the dominant species, that's where you have the pink. And then when the other complex, the cobalt chloride complex is formed, that's where you're getting the purple color. So you can see that these are going way into the purple direction here as it's heating up. But this one is still relatively pink, even though it's at the same temperature as these other test tubes. And that's a good question, why? What's different about that one compared to the other 2? And then the next part, we've got them at the high temperature. We've added some heat, and it's forcing the equilibrium toward the other side. Why? And then we're going to take them, put them in our ice water bath here, and cool them down. And what do you suppose is going to happen as they cool? I should point out also that we lost Wendy, our camera person for today, and so Elizabeth Libby is doing the camera for this part, and then I'll do the camera for the next part there. And lo and behold, as they're cooling down, what are you seeing? That color seems to be going back to pink. We're putting them in an ice water bath, we're cooling them down, we're taking heat away. What's going on in terms of Le Chatelet's principle? That's what you need to explain. Okay? They want the HCl, they want the ammonium chloride, the control, and of course, whoops, that's deionized water, my room temperature control. Very good.
hello, yes. So we are going back and forth between days. Time warp. I'm going to kind of have Dr. Snipes, let's take a look at the chemistry for this one. Actually, we have iron 3 reacting with thiocyanate. That's the SEN negative one. The iron 3 generally has a kind of a tan color. And then the iron 3 thiocyanate complex on the product side, that's kind of this cool blood red. So, I just gave it away. So let's kind of take a look at what we're doing. We only have 2 reactants, so your instructions are to go ahead and take 1 ml of your iron 3 nitrate, and the nitrate is a spectator ion. And we want to make sure it's just 1 ml instead of like the whole thing. All right, there's 1 ml. Okay, then the other reactant is the thiocyanate. We're going to use potassium thiocyanate, and here we go. Whoa, I love that.
What happened, Mr. Wizard?
It's a chemical reaction. It's forming that thiocyanate complex, iron 3 thiocyanate
And that's
complex.
like a deep blood red.
Yeah, that's way
That's-
crazy.
yeah, that's
So record your observations. The next thing it says is we're going to dilute that up before we go ahead and stress it. So we're going to dilute up the equilibrium. This is just 50 mils of DI water. Oh, very nice. And I've got some stirring rods here. We'll go ahead and make sure we have that homogeneous. All right. So your instructions say to go ahead and fill 5 milliliters in each of 3 test tubes. So I've actually got marks here for the 5 milliliter mark. So,
These qualitative tests, the volumes are not super critical.
right, plus or minus. Now, definitely a lot of our other labs are quantitative. Like the one we're doing next week, we'll use the same equilibrium and we'll be a little more precise with our volumes. Okay, so I've got 4 identical test tubes here, and I'm going to stress the system and we'll see what we got going on here. So to the first test tube, I'm going to add more reactant in the form of iron 3. Okay. Let's go ahead and give it a 1 ml shot. See what we got. See if we see a color change. Oh, I was going to say subtle, but I don't know.
What happened?
I'm going to go ahead and compare. This has been stressed with iron 3, and this is our control. So yeah, what are your observations for those two? Okay, I'm going to stress the second one by adding the other reactant, which is the thiocyanate. 1 ml. Let's see what we got. Ooh, okay. Adding a reactant will favor the equilibrium to
Oh
do
my
what?
goodness, it looks even darker red.
Let's see, let's compare it to the control. All right,
I hope somebody can explain to us why.
please, we're looking forward to that. Okay, the third way I'm going to stress the system actually is to add sodium hydroxide. And if you read your background information, what sodium hydroxide is going to do is actually complex with your iron 3. So it's going to it's like removing iron 3. So here we go.
Yeah, we can't physically reach in there and pull out the iron 3, so we have to do it a different way to take iron 3 out of our system.
Very clever. Okay, so I'm like removing a reactant. What will that do? Ooh, nice.
Wow, it's like magic.
I'm going to show you the control. So this has been stressed by adding hydroxide, which removes iron 3. So this is the stressed one, and this is the control. Now, I do see a color difference.
Again, the red color is because of the complex ion being the dominant species. The tan color is back because of the iron 3 ion in this solution, giving it that color, of course.
Okay, so keep us posted if you
Very good. Explain, explain, explain.
One more.
This one is actually a look at 2 different equilibrium systems, because we're going to study the equilibrium between the solid phase silver chloride and its dissolved phase. Keep in mind when that solid is dissolved, it goes into its component ions. The ionic compound breaks apart into its component ions, Ag plus and Cl minus. And then the other equilibrium that we're going to look at will be the complex ion that's formed between silver and ammonia, but AgNH3 taken twice with a plus 1 charge on it, that equilibrium system as well. And you can see that in that equilibrium, the ammonia is in a sense reacting with the silver ion to produce that complex ion that's over on the right-hand side of the chemical equilibrium equation. And so we kind of explain, again, more information than we should give you probably, what's going on as we do these experiments here. And so there's the procedure. Let's say it says place about 3 milliliters of 0.1 molar silver nitrate into a test tube, which I've done here. Okay? And then add a few drops of 0.1 molar NaCl. So it's about 5 drops or so. And let's see what happens. It's 1 drop, I'll do my
Ooh, there it goes.
2 drops.
Oh, that's so cool. They're all my favorite, but I like that one.
4, 5.
Well, it's not.
What happened?
Hold on, hold
Time
on.
out, time out, Dad.
Being funky again. There it goes.
What happened? Can you see that there's a lot of solid now where there wasn't any before? Why is that? Gosh, I wish I knew. I wish somebody could explain it to me. You know, maybe wishes will come true. We'll see. Okay. All right, and then the next step, well, it says mix with a stirring rod. Hey, okay. You can see again, there's a lot of solid in there. Okay. And then the next step, add about 1 milliliter of 3 molar ammonia, NH3, okay, aqueous.
Ooh.
Can you tell anything?
I can. Boy, that ammonia smells funky.
Can y'all smell that?
Stop stirring it. It's not picking up.
Looks
Yeah.
a lot clearer to me.
It's kind of clumped there on the bottom. Then I'm going to add another milliliter. I'm going to break that clump up as best I can there. And then I'm going to add another milliliter of the ammonia. And I'm going to stir it.
Nice. You still got some particulates,
Still
but
got
it's a lot
some
less
there, but
than-
can you tell the amount of the solid if I stir
a
it?
lot less. That's cool. A lot less than it was before.
Yeah, I wonder what would happen if I added some more.
Trying to get it against a dark background. That helps. Yeah, that's good.
Whoa, it's like almost clear.
What happened? Why did it disappear?
I wouldn't drink it though.
I don't know. Gosh, I hope
Solid's
again.
going away.
I hope that somebody can explain it to me. That's pretty neat.
Yeah, I like
Pretty
that.
cool.
I
Okay.
like that.
Well, folks, that is the aqueous solution, or excuse me, the Le Chatelet's principle experiment. And I hope that it's okay watching the video, and we'll just kind of end here. And then you'll have another one for next week.